If you see, guys, we have a story. So Alan went for trekking. So on the way, he has to cross a stream, and Alan did not know swimming. So Alan did not know how to swim this one. So what he did is he started exploring for an alternative routes to use to cross over. So he started exploring the alternative routes. Suddenly he saw a sign post which said that average depth is 3 feet. So he had seen a sign post saying that average depth is 3 feet. So what he did, as the average depth is 3 feet and Alan is 5 feet 7 inches high, so he thought that he would cross the stream. But unfortunately, he had not reached the other end. Unfortunately, he had not reached the other end. What is the reason why he had not reached the other end? The story is this. If you see, the average depth is 3 feet. If you see, the average depth is 3 feet. But at one places it is 1 feet height. At one places it is 2 feet height. At one place it is 7 feet depth. So that is the reason he couldn't cross over. So what is the story that we have to know from this thing? The story is we should always be aware of the averages. So never believe something called as average. So that is an example of statistical things case. That is an example of statistical concepts. That is the reason we always should not believe certain mathematical concepts, or we should not really correlate certain mathematical concepts with the real time examples, because always the mathematical concept will not match that scenarios. So here, the signboard of average depth is not suitable to keep. So instead of that, what they have to use minimum depth is 1 feet, maximum depth is 7 feet, something like that, so that he might have taken care that at some point it is 7 feet, and he might have easily crossed the other place or anything. He might have looked for the alternative. So here the story of average, we should never believe the averages case. That is a statistical example concept. Okay. Now let us go to another example. If you see here, if you see here, this is the story of LinkedIn. So statistics of LinkedIn 2014, what it is saying is LinkedIn has 313 members in 200 plus countries. So LinkedIn has 39 million students and recent college graduates. So if you see, LinkedIn has 313 million people in 200 plus countries. So 313 million members are there, in fact, in LinkedIn. And out of that, 39 million were students and recent college graduates. So out of the 39 million, okay, out of that 330 million people, 39 million people were students and recent college graduates. And 3 million companies with LinkedIn pages are there. And we have 2.1 million LinkedIn groups. We have 1.5 million unique publishers. And 45% of the people visits LinkedIn via mobile phones. 35% of the users access LinkedIn daily. Okay, so out of 100%, 35% of the people access LinkedIn daily, guys. And every 17 minutes. So, what is the average time spent? So, on an average, a user spends 17 minutes of time in a month in LinkedIn. And every two new users join every second. So, two new users join every second. And 60% of the users industry interests are into industry insights. So 60% people are interested in the industrial insights. So this is the story of LinkedIn. So these are some statistics related to LinkedIn. Now, now let us discuss few things. Do these statistics tell you a story about LinkedIn, guys? Do these statistics tell you a story about LinkedIn? Do you agree with me? Yes. The statistics tells the story about the company LinkedIn. And if you see, if you are a recent graduate, what would these statistics mean to you? Suppose, for example, guys, think that you are a recent graduate, which of these statistics is interesting for you? What you will be interested in more? So which will be matching to you? So if you see here, 39 students are recent college graduates. Okay. So that is one which is matching. If you work in marketing department, what decision can you make about your digital marketing strategy? So if you are working in the marketing department of a company, so what you can do, you can have a LinkedIn page, you can create a group. Okay. Next, if you want to know to the global audience, do you think LinkedIn is the right channel? So tell this guys. So if you want to become popular to the global, or if you want to reach the global audience, is this LinkedIn a right platform? Any one
Yes,
of
sir,
you?
because it has many members across 200 plus countries.
Yes, exactly. So it has many members and other things. So it is a right platform to reach global audience. So if you are a recruiter, think that you are a recruiter, would you post your job requirements in LinkedIn? So if you are a recruiter, would you post your job requirements in LinkedIn?
Yes, sir.
Yes. Why? What is the reason?
Oh,
Yeah.
3 million companies
So
pages. So most of the companies are already on this platform. So it's easier to get a job.
recruiter, I'm asking recruiter. That means if you want to recruit someone,
Then the it has 39 million students. So
yes, it has 39 million students are there. Okay, so many people, many 313 million members are there. So definitely, if you are a recruiter, you will definitely post the job in the LinkedIn. Okay, so that is the one. So now, if you want to invest in the stock, will you buy LinkedIn stock? So if you are if you want to invest, do you buy LinkedIn stock? Yeah, maybe because if you see every two new users join every second, so that means a lot of people are joining in LinkedIn, right? So if you see here, here we have some statistics about LinkedIn. So based upon the statistics, we can answer some questions. We can take a decision whether to invest in the stock of LinkedIn or not. So similarly, statistics means some metrics which will speak about a person. Suppose a person, if you take his percentages, his merits, his demerits. Suppose if you take a country, what is the population of the country? What is the per capita income of the country? What is the value of the currency of that country? How many people are graduated? How many industries are there in that country and all? So that statistic speaks about that country. So statistics are nothing but they are some metrics which speak about some person, some country, some company, some industry, like that. Okay. So if you see what is exactly statistics. So let us see the definition of the statistics. What is exactly statistics? Statistics is nothing but it is collection, organization, analysis, and interpretation of data. So what is statistics? Statistics is nothing but it is collection, organization, analysis, and interpretation of the data. So what we take some data, we collect some data, we analyze that data, we interpret that data. So what is statistics? Statistics is collection of organization, analyzation, and interpretation of the data. So we have different types of statistical includes. Mainly we shall see what is descriptive statistics, what is referential statistics. We shall see into probability theorem also. So what is descriptive statistics? Descriptive statistics is descriptive in nature. For example, the income of a person, the height, age, other things of a person. So the information that gives about a person or a company, the statistics that are called as descriptive statistics. What is his minimum salary? What is his maximum salary? Okay. So what is his average salary? So this type of things are called as descriptive statistics. And then we have something called as inferential statistics. What is inferential statistics? Inferential statistics means, for example, a person is there. Okay. So a person went to a mobile showroom and he want to purchase a mobile. So immediately the shop person, what he does, he take a iPhone 16 and he shows to that person. "Hey, this is iPhone 16 and it cost is 1 lakh 20. Please purchase this one." But the person cannot purchase that mobile. Why? Because it is out of range of his salary. He's getting a salary of only 25,000 K per month. But the shopkeeper is showing a mobile which is of a high cost, which is out of reach to that person. So inferential statistics means correlating two events. So correlating here his salary and the product the salesperson is showing to him. Okay, so that type of statistics is nothing but differential statistics. Fine. So if you see what is the definition of statistics, statistics is collection, organization, analysis, and interpretation of data. So what is statistics? Statistics is collection, organization, analysis, and interpretation of data. Okay, and if you see in statistical analysis, okay, so in statistical analysis, three fundamental concepts are associated with describing the data. So there are three fundamental concepts which associates with describing the data. So what are those fundamental concepts which are associated for describing the data? So number one, it is location or central tendency. Number two, dispersion or spread. Number three, shape or distribution. So these are the three fundamental concepts. But anyway, we are going to see one by one. What is location or central tendency? What is dispersion or measures? What is shape or distribution? So main thing what you need to remember is in statistical analysis, the three fundamental concepts are associated with describing data. They are nothing but location or central tendency, dispersion or spread, shape or distribution. So these are the three things. Now let us see one by one. So let us see what is central tendency. So what is meaning of central tendency measure? So if you see the definition of central tendency measure, a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. In other words, central tendency computes the center around which the data is distributed. Okay, so let us take this thing into consideration. So, what is central tendency? Is central tendency computes the center around which the data is distributed. So, what are the three measures of central tendency? So, what are the three measures of central tendency? Are mean, median, mode. So these are the three measures of central tendency. Okay. So central tendency computes the center around which the data is distributed. We have three measures of central tendency. One is mean, another is median, another is mode. Okay. Next, let us see one by one. What is mean? Okay. So mean. Mean means arithmetic mean, guys. Mean means arithmetic mean. So you all know what is mean is. So mean is nothing but x bar summation of I equal to 1 to n xi by n. So what is x1, x2, x3? They are nothing but the number of observations or the number of observed values. So what is n? N is the sample size. So this is mean. So for example, if you take a data, for example, I have a data points. So I have 1, 3, 3. So 1, 2, 3, 4, 5. So what is the mean for this data? So I have 1 plus 2 plus 3 plus 4 by 5. That is 15 by 5, 3. 3 is the mean for this data. So if you take this data, here I have points 1, 2, 3, 4 and 10. I want to calculate the mean. So what is that? 1 plus 2 plus 3 plus 4 plus 10 by 5. That is 20 by 5. We got 4 as the result. So 4 is the mean. But with mean, we have some problem. So always we should not take the mean. What is the problem with mean is, for example, I want to calculate what is the mean of the salary of three persons. So I want to take three persons salary and I want to calculate the mean of their salary. So first person I'm taking, I'm taking Suresh into consideration. So Suresh is getting around 50K. Second person I'm considering Ashish. Ashish is getting around 70K per month. Third person I am considering Mukesh Ambani. He is getting a salary of 300 crores per month. So if you take their averages, it comes around 145 or it comes around, let me say it comes around 100 crores. So do Suresh salary near to 100 crores? Is it near to 100 crores? Not at all. Is Yogi salary near to 100 crores? Not at all. So what is the problem of mean? The problem with mean is affected by extreme values, or we call that values as outliers. So if you see this Mukesh Ambani salary, what is that? That is an outlier. It is an extreme value. So mean is affected always with the extreme values, and when we have outliers, especially in the data, we should not consider this mean because mean is sensitive to outliers. Do remember one thing. Okay. So what we have to do? So when mean is sensitive to outliers, then what we need to consider is we need to consider median into consideration. So what is median? Okay. So median, when we order a data, for example, here on the screen, we have something called as 0, 1, 2, 3, 4. Okay. So what is median? Median is the middle number. So if you see, median is the middle number. For example, if you take this data 1, 2, 3, 4, and 10, what is the median? Median is 3. For the same data, if you take mean, you will get mean as 4. Okay. So what is median? Median is the middle number. So always we will not have middle number. Okay. For example, when we have odd number of observations, we have mean, middle number. But when we have even number of observations, what we have to do? The median is n plus 1 by 2. Okay. Or else what we have to do? We have to take, suppose for example, for this data, 1, 2, 3, 4, 5. What is the median? Median is 3. So median is nothing but the middle number. So here it is 3. That is median. For example, if you have a data like this 1, 2, 3, 4, 5, 6. So in that case, what is the median? The median is we take the average of middle two numbers. So we take 3 and 4 are the middle two numbers and we take the average of 3 and 4. Then the median is 3.5 for this respective data. Okay. And next, if you see here, if you see the data is 1, 2, 3, 4, 5. But always the data will be not like this. So sometimes the data will be like this case. You see here, the points are like this 2, 3, 1, 3, 1, 6. So when the data is like this, immediately you can't take the middle two numbers. So in fact, what you have to do is you have to order this set of data into ascending order or descending order. So now what I'm doing, I'm arranging this one into ascending order. So when I ascending the order, what are the two middle numbers? 2 and 3. Now the median for this data is the average of this 2 and 3. So we got 2.5 as the result. Okay. So this is how median is taken into consideration. Next, another measure of central tendency. So what are the other method of central tendency is calculating the mode. Okay, taking the mode into consideration. So what is mode? Mode is nothing but it is the most often occurring thing. Sometimes for a data, there might be no mode. For example, if you see here in this data, for this data, we don't have any mode because none of the item is occurring twice. If you see for this data, the 9 is occurring 3 times. So 9 is mode for this data. So what is mode? Mode is the value that occurs more often. So in this data, 9 is occurring more often. So 9 is the mode for this data. So here we don't have mode for this data. Okay. So that is the thing. And if you see this data, so come here. So what is the mode for this data? So here we have points 1, 2, 2, 2, 3, 3, 4. So 2 is the most occurrent event, though 3 is occurring twice, but 2 is occurring thrice. So 2 is the mode for the data. Now, if you take this data, if you check this data, so in this data, we have 2 occurring twice and 3 occurring twice. Then what is the mode for this data? So mode for this data is this data has two modes. And when a data has two modes, we call it as bimodal. So here 2 and 3 are modes for this data. Okay. Sometimes we may have a data like this. So how we have like this 2 times, 3 2 times, 4 2 times. So if you see three items are occurring twice. So what is the mode for this data? The mode for this data is this 2, 3, and 4. So this type of mode is called as multimodal. So this type of mode is called as multimodal. Okay. And and now if you go back. So we are discussing regarding the central tendency. What is central tendency? Central tendency is nothing but okay. Central tendency computes the center around which the data is distributed. So we have three measures of central tendency. What is that? Mean, median, mode. So we had discussed what is mean. We had discussed what is median. We had discussed what is mode. Okay. So now let us move to the other concept called as weighted mean. Okay. So come here. So we are discussing another concept called as weighted mean. So what is the difference between a mean and weighted mean? Okay, what is the difference between what is mean and what is weighted mean? So mean means case, for example, if I have 10th class people are there, 10th class people are there. Suppose if I calculate what is the average marks, or you can say mean of max, what are the max average marks, then we call it as mean. What is the average marks in max? Suppose in 10th class only, I have 10th class A section and I have 10th class B section. Suppose if I calculate the mean over two groups, if you see 10th class A section, that is one group. 10th class B section, that is another group, second group. Suppose if you want to calculate the mean over a group, then that is called as weighted mean. So if you are calculating the mean, so what is weighted mean? Weighted mean means finding the overall mean of two separate groups. That is called as weighted mean. Right? So let us see the concept of weighted mean. What is weighted mean? How this weighted mean is calculated? And what is the behavior of weighted mean? How this weighted mean behaves and all. So we shall see that concepts. Right? So please confirm if you are with me, everyone listening with me or not. So please, everyone, please confirm with NS in the chat or
Yes,
S.
sir.
Yes, sir.
Okay. Fine. Fine. Yes. So let us see what is this weighted mean. Come here. So this is the formula for weighted mean, guys. So what is the formula for weighted mean? Weighted mean equal to mean of group 1 into n1 plus mean of group 2 into n2 by n1 plus n2, where n1 is the size of the first group. So this is the mathematical formula for weighted mean. So is it mandatory to remember the formulas? It is not mandatory to remember the formulas, guys. No need to note down the formulas also. Just remember the stop concept. Where to implement which type of mathematical concept is important. That is the reason in the starting, I had told you the story of Ellen. Okay. So listen to the concept and try to correlate the concepts. So weighted mean, the formula for weighted mean is nothing but mean of group 1 into n1 plus mean of group 2 into n2 by n1 plus n2. So what is n1? It is size of first group, n2 is size of the second group. So n1 is size of the first group and n2 is size of the second group. Okay. So now, if you see, now I am going to an example. Just look at this example. So here this is 10th class A section. This is 10th class B section. So when 10th class A section, N1 is 20, that is N is the number of students is 20. And 10th class B section, when number of students is also 20. So if you see N1 and N2 both are equal. When mean of group 1 is 90, the mean of group 1 is 90 and the mean of group 2 is 110. Okay, so if you calculated the weighted mean, so what is weighted mean? Mean of group 1 into n1 plus mean of group 2 into n2 by n1 plus n2. So what is the weighted mean? Weighted mean is nothing but 100. You see here. Okay, so this is 100. So mean of group 1 is 90, mean of group 2 is 110. And what is the weighted mean? Weighted mean is around 100. Now second scenario. In second scenario, 10th class A section, we have 10 students. 10th class B section, we have 30 students. So mean of 10th class A section is 90, mean of 10th class B section is 110. And now if you calculated the weighted mean, it is coming around 105. So 90, 110, and mean is 105. Okay, so this is one scenario. See here, sizes of N1 and N2. Okay, now another scenario. In this another scenario, 10th class A section has 30 students, 10th class B section has 10 students, and 10th class A section mean is 90, 10th class B section mean is 110, and if you calculate the weighted mean, it comes around 95. Okay, so here N1 is 30, N2 is 10. Fine. Now, if you go to the scenario, so what scenario is saying is Do remember, guys. In first scenario, N1, that is 10th class A section people are 20. N2, 10th class B section people are 20. So what is weighted mean? Weighted mean is 100, which is exactly in the middle. So 90 and 110. So weighted mean is 100. So when N1 equal to 20 and N2 equal to 20, so equal size, the weighted mean is exactly at the center. Now, second scenario. This is first scenario. Second scenario. 10th class A section is 10. 10th class B section is 30. So 10th class A section mean is 90. 10th class B section mean is 110. And what is weighted mean? It is 105. So here N1 and N2 is greater. 36 people are there. So what it is doing, it is pulling the weighted beam towards its side. It is pulling the weighted beam towards its side. Now third scenario, N1 equal to 30, N2 equal to 10. So mean of 10th class A section is 90. Mean of 10th class B section is 110. So what is the weighted mean? 95. It is coming here. So here in this scenario, N1 is 30, N1 is greater than N2. So if you see weighted mean is pulled towards 90. So overall weighted mean is 95. So the mathematical concept is equal group sizes. When N1 equal to 20 and N2 equal to 20, the weighted mean is exactly in the middle. When group sizes are different, okay, so the weighted mean will be closer to the mean with larger n. Okay, so wherever larger n is there, suppose here in this scenario, 10th class B section is larger population, so it is pulling the weighted mean towards its side. In this scenario, 10th class A section people are more. So in this scenario, it is pulling the weighted mean towards its side. Okay, so what is the inference we have to get here is the weighted mean takes into account the size of each group. When group sizes are equal, so when group sizes are equal, the weighted mean is exactly in between. Suppose, for example, when group sizes are equal, so N1 equal to 20, N2 equal to 20, weighted mean is 100. Exactly at the middle. When group sizes are unequal, the mean with larger n has greater influence, pulling the overall weighted mean of the two groups close to you. Okay, so when n1 equal to 10 and n2 equal to 20, so weighted mean is 105. It is pulling. When n1 equal to 20 and n2 equal to 10, weighted mean is 95, pulling towards 90. So that is what the concept of weighted mean is. So weighted mean takes into account the size of each group. When group sizes are equal, the weighted mean is exactly in between the two groups. When group sizes are unequal, the mean with larger n has greater influence, pulling the overall weighted mean of the two groups closer to it. So this is what weighted mean is. Okay. Next concept is dispersion measure.